Hello students, welcome to the new video of Module 2. The previous video taught us about the AWS Lambda execution environment and its life cycle. In this video, we will learn about Lambda performance optimization. We will see what a cold start and a warm start is and how we can minimize the cold start time. So let's get started. When AWS Lambda requests to run a function via Lambda API, it first prepares an execution environment. While performing this step, the service downloads the code for the function, which is stored in an internal S3 bucket. It then creates an environment with specific memory, runtime, and configuration. Once completed, AWS Lambda runs an initialization code outside of the event handler before finally running the handler code. In this diagram, the first two steps are for setting up the environment and the code. These steps are frequently known as cold start. Charges are not applied for the time when Lambda is preparing the function, but it surely adds latency to the overall invocation duration. After completing the execution environment gets frozen. When that happens, Lambda retains the execution environment for a random period of time to improve resource management and performance. If another request arrives during this time for the same function, the AWS Lambda can reuse the environment. This second request finishes more quickly because the execution environment is already in existence and it won't be necessary to download the code and run the initialization code. This is called a warm start. An analysis of production Lambda workloads predicts that cold starts typically occur in under 1% of the total invocations. The duration of a cold start generally varies from under 100 milliseconds to over 1 second. Cold start occurs more common in development and test functions rather than in production workloads because Lambda optimizes internally based on invocation patterns for functions. This happens because development and test functions are usually invoked less frequently. Overall, Lambda optimizes the execution of functions across all customers to reduce the number of cold starts. Minimizing the cold starts. First, by writing functions using interpreted languages, we can cut down the time impact of cold starts. Cold start latency with Python and Node.js is under 1 second, and a compiled language like Go is another good example of low cold start latency. Second, another easy step for reducing cold start is by choosing higher memory settings for the functions, and this also provides the functions with more CPU power. Third, if we need predictable function start times for our workload, provisioned concurrency is the recommended solution to get the lowest possible latency for sure. This feature keeps our functions initialized and warm and is ready to respond in milliseconds. We will learn about concurrency in the upcoming module. Fourth, another way to reduce the number of cold starts that occur in the first place is with function warming. This is the act of sending scheduled ping events to our functions to keep them alive and idle and ready to serve requests. Using Amazon CloudWatch events, we can trigger the functions periodically to always have a fixed number of AWS Lambda instances alive. Just set it up so that it will trigger the function every 5 to 15 minutes and rest assured, it will always be idle. In order to correctly warm the functions, follow some simple steps. First, the function shouldn't be invoked more often than once every 5 minutes. Second, invoke the function directly using Amazon CloudWatch events. This is all about the AWS Lambda performance optimization. In the next video, we will learn about the AWS Lambda permission overview.